Conditional probabilities are extremely important in every industry. Okay, whether you're looking at FDA drug approval or you want to know what proportion, answer questions like what proportions of these kinds of people have a certain kind of cancer, conditional probabilities pop up all the time. You know, what proportion of people who test positively to a test for a certain disease actually have the disease. Okay, these are really important kinds of things. Now, here's the idea. First of all, what does this mean? This you can read as the probability of A given B has occurred. Okay, so this line here is the given symbol. It means given. You want to know the chance of A given that B has occurred. Think of this stuff that appears on the other side of that line as additional information. Okay? All right? Additional info. So here's the idea in our cartoon world here. Let's say that I'm really interested in the chance of A occurring. All right? Now, maybe A is the event that, I don't know, that you win the lottery. Okay? What's the chance that you win the lottery? I don't know, it's probably pretty small. But what if somebody comes along and says, hey, I have this extra information. It's called B. And maybe B is, I don't know, guess what? I know that I know who's won the lottery, and it's either you or your brother. Okay? Whoa! Suddenly that changes things in a great, humongous way, right? Now it's down to 2. You might say you have a 50-50 chance, right? If it's down to you and someone else, right? So given additional information, it can change the chances of events occurring in a huge way, right? So let's see how we can arrive at this formula. If I want to know the chance of A occurring, you know, I know what that is. The probability of A is just sort of the area here in A, right? I could even write it like this, right? The chance of A divided by the chance of getting something in the sample space, all right? Right? Because I know that by probability axiom number 2, the chance of getting something in the sample space is actually 1, right? So this is, you know, this is pretty stupid, but it's true. Now, if I come along and I say, hey, guess what? B has occurred. Now what is the chance of A? Well, if I tell you that B has occurred, now I'm just going to throw away all of this stuff because guess what? B is my new sample space. B is my new sample space. See that? If I tell you B has occurred, then none of this other stuff matters. B is my new sample space. B is my new sample space. But the area of it is not 1, okay? So keep that in mind. The area of this new sample space is not 1. But if I'm given that B has occurred, now what's the chance that A occurs? Well, shouldn't it just be the area of this region right in here divided by the area of B? Yeah, it should be this area right here, which is this, divided by the total area of B, which is this. Yeah, so in fact, that's exactly why we define the probability of A given B to be equal to the probability of their intersection divided by the probability of B. Okay, so for example, suppose that 2% of students are double majoring in agriculture and business, and let's say 3% of students are majoring in business. So given, keyword there, given that a randomly chosen student majors in business, what is the probability that he also majors in agriculture? Okay, well then I can just follow the formula there. It's the probability of someone is ag and business divided by the probability that a person majors in business. Okay, So 2% are double majoring, right? and 3% are business majors. That's 2/3, right? Is the chance. Or you could write that as 66.6 repeating percent. Okay. See that? What percentage of the students are ag majors? I don't know. In our class, I think we have 2 out of 100 or so. It's like 2%. Okay, it's really pretty small. Okay, but if I'm given that a student is majoring in business, then what's the chance that we have an ag major? Well, suddenly maybe it's a lot higher. Okay, all right. So let's try another example. If you roll a white die and a green die, what's the chance that the white die shows a 3? Okay, shouldn't that just be 6 out of 36, or 1/6? What's the chance that the white die shows a 2? Again, that's 6 out of 36. I'm counting 36 here because there are 36 possible outcomes when you roll a white and green die, right? 6 outcomes for the white, 6 outcomes for the green. Okay. Now, how do these chances change if you're given that the sum is 4? Now what's the probability that the white die shows a 3? If I'm given that the sum is a 4, how many ways can you get a sum of 4? Well, it's like this. If I do the white one on my left hand and the green die on my right, okay, how many ways can I get a sum of 4? I can get that with a 1 and 3, 2 and 2, 3 and 1, right? There are 3 different sums of 4. 3 different sums of 4. There's only one way to get double 2s, right? So what's the probability? So this will be the probability that white equals 3 and that I get a sum of 4 over the chance of getting a sum of 4. Okay? So the top part, let's see, what's the chance that I get that the white is a 3 and the sum is 4? There's only one way out of 36, right? Sum is 4 and the white is 3? There's one way. Okay. What's the chance, though, that the sum is 4? We already established that as 3 out of 36. That comes out to be a 1/3. Okay. Nice, right? Similarly, what's the chance that the white die shows a 2 given that the sum is a 4? I think it works out to be the same. Okay, it's also a 1/3. What about example 7 here? What's the chance that the white die shows an even number? An even number. So that I could write it like that, right? White is even. What's the chance that the white is even? Pardon my slop there. What is the chance that the white is even? It's well, how many ways can you do that? So the white die, if you're still rolling 2 dice, a white and a green die, there are 18 ways out of 36 that the white die shows an even number, right? Okay, or 1/2. Okay, reduces to. What's the chance that the white? Whoops, sorry. The chance that the white is odd. Also, 18 out of 36 by the rule for complements, right? It's either going to be even or odd. What if you're given the additional information that the sum is at most 4? What's the chance that the white is even given the sum is at most 4? Okay. Well, for that, I think maybe I'm going to draw a little picture. Okay. So by white, I mean black. Okay. 1, 1, 1, 1, 1, 1. 2, 2, 2, 2, 2, 2. I'm choosing to draw a picture now because I just can't seem to keep all this stuff in my head. Okay. And when problems get too complicated for me to think about, then I just resort to drawing pictures. Maybe painting, do a little watercolor. I don't know. Helps to account for all the possible things that could happen. Okay? Now by white, or by black, I mean white. Okay? And by green, I mean green with the red cap. This is 1, 1, 1, 1, 1, 1. 2, 2, 2, 2, 2, 2. We did something like this in class, right? This is my sample space when I roll a white die and a green die, right? There are 36 possible pairs here. So for example, if this outcome occurs, this one right here, it means that the white die showed a 2 and the green die showed a 5. Okay? Makes sense? And this outcome over here means that the white die showed a 5 and the green die showed a 3. All right? So we want to know what's the chance that the white die is even given that the sum is less or equal to 4. So where are the sums that are less or equal to 4? They're right in here. Okay? So probability that the white is even given sum is less or equal to 4. I could say that's the chance that the white is even and the sum is less or equal to 4 divided by the chance that the sum is less or equal to 4. Okay? So what's the chance that the white is even and the sum is less or equal to 4? First of all, there are 36 possible outcomes total. So now what's the chance that the white is even and the sum is less or equal to 4? There are two ways to get the white is even up here, right? Okay, so that's 2 out of 36. Now, what's the chance that the sum is less or equal to 4? That's 1, 2, 3, 4, 5, 6 out of 36. The answer is just 2/6 or a third. Okay? See that? So, hey, look, I used the formula for this, right? You see that? I applied the formula for this to get this so-called conditional probability. You don't have to do that if you can draw a nice picture like this. See, if you can visualize it like this, given that the sum is less or equal to 4, now I can throw all this stuff away. Now, here's my new sample space. Now, what is the chance that the white die is even, that the white die shows an even? Hey, look, it's 1, 2 out of 6. Two ways to accomplish that out of 6. The answer is 2/6 or 1/3. Okay? Fantastic. Good job.